Hey everybody, and welcome to today's lesson about rotations. Let's get right to it. A rotation of x degrees about point Q, which also means around point Q, and that's called the center of the rotation, that point Q, is a transformation with these two properties. The image of Q itself is Q prime. Okay, that point Q does not move. All right. I'm rotating the whole figure around it, so if I were to rotate Q, it just stays in that one little spot. For any other point, the measure of the angle from the original point to Q to the new point is that degree of the rotation. Okay, so in other words, the measure of angle V, Q, V prime in this example is x, the degree of the rotation. Okay, for a little bit of notation here, we use the capital R to show that we're doing a rotation, and then down in the subscript, we're going to say the degree of the rotation, and then we're going to talk about what is the center of the rotation. That goes down in the subscript, and then just like all the other transformations, we're going to talk about what I'm actually rotating, and then what the resulting figure is, or my image is. So this is triangle U prime, V prime, W prime. Okay, let's talk about how to do a rotation. Today we're going to talk about doing a rotation by hand and also doing a rotation on the coordinate plane. Alright, now you're going to have to bear with me here. I don't have a protractor with me, so all my rotations are going to be an estimate. I'll do my best to do it justice. So the first step here, we actually want to draw a line from the center of rotation P to each one of my vertices, and that works out well here because both of these vertices lie on the same line. So I'm going to draw another line from P through A, okay, and then a line from P through D. Okay, now I'm going to take each one of these lines and I'm going to rotate it 60 degrees. Now, a positive rotation means we are moving in a counterclockwise direction. Okay, we're moving in that counterclockwise direction. So this first line here I'm going to take and it's going to get rotated 60 degrees. We're going to kind of eyeball this. We'll say this looks like about 60 degrees. Go here. Okay, now I'm going to rotate this line through A 60 degrees. Okay, and then I'm going to rotate the line that goes through D 60 degrees. Okay. All right. Again, I'm eyeballing it here, so in a moment, it's the moment of truth. The next step then is to measure the distance from P to each one of your vertices. So I'm going to measure from P to C, and then I'm going to measure that same distance on my rotated line. Okay, so it looks like about right here. That is the point C prime. I'll do the same with B. I measure out this way. So this looks like B prime. I'll measure the distance from P to A. It's way out there. I'll measure that same distance here. All right, this looks like A prime. And then here, measure the distance from P to D. Measure that same distance along this line. Okay, and I get D prime. When I connect my points, I should end up with a rectangle that looks exactly the same as the original, just rotated 60 degrees. All right, and you can see that mine's just a little bit crooked, but all in all about the same. Now, this is one of the most important pieces here. If you look at the measure of the angle between here, C prime to P to C, the measure of this angle should be 60 degrees. All right, let's look at the next problem. Why don't you give this one a shot? You should be using a straight edge and a protractor here. We're going to try to rotate this figure 90 degrees. Pause the video, do your rotation, and then check your answer. All right, so I've got to start by drawing a line. Let's use red here. I'm going to draw a line from P through each one of my vertices, and this works out nicely because A and B lie on the same line. And then a line from P through C. Okay, and then I'm going to go ahead and rotate these lines 90 degrees. I'm moving in a counterclockwise direction because it's a positive rotation. So 90 degrees from the line that goes through AB would be over here. Okay, and then 90 degrees from this one would be about here. Okay, I now need to measure from P to my points. So this is from P to B would be about right here, and label that B prime. And then to A is about here. Okay, again, this is just an estimate for me. Yours should be much more exact. And then to C is about here. Okay, now when I actually connect my points, I should end up with that triangle, but rotated 90 degrees. Okay, some varying degrees of success there. That C should probably be a little bit further down here, but you kind of get the picture. All right, now if I'm going to rotate in the coordinate plane, there's some cool things that happen here. You can see a rotation of 90 degrees here. So again, I'm moving in that counterclockwise direction. I move from the first quadrant to the second quadrant. A rotation of 180 degrees. Again, counterclockwise, boom. That's at half a turn. I move from the first quadrant down to the third. Okay, 270 degrees wraps us 3/4 of a turn. I go from the first to the fourth quadrant, and then a 360 degree rotation. That is one full swing around, and I end up right where I left off. Now there's some interesting patterns that you see here with our ordered pairs. So if I were to reflect 90 degrees, what ultimately happens is that my ordered pairs flip, and the sign of the y-coordinate changes. For 180, the sign of both ordered pairs changes. For a rotation of 270, I again flip x and y, and now I change the sign of the x. All right, let's put that into practice. I have rewritten some of the patterns that arise up here, and we're going to go ahead and try to rotate this triangle some various degree measures. I'm going to go ahead and plot A, B, and C here. So this is A. B is over 3, -2, and then C is -1, 3. Okay, gonna go ahead and connect those dots. It's not the prettiest triangle I've ever seen, but it'll do for now. All right. Now, I find it helpful to write down my image points. All right, so A prime. A started off as 2, 2. If I'm going to rotate 90 degrees, I need to flip-flop x and y and change the sign of the y. So this is going to become -2, 2. For B, flip-flop x and y and then change the sign of y. So this should be 2, 3. And then for C, flip-flop x and y and then change the sign of y. So this should be -3, -1. Let's go ahead and plot those points and see what we've got. A is -2, 2. Okay, going from that first quadrant to the third quadrant. You can think about that. You should just be moving one quadrant over. B is now at 2, 3. So over 2, up 3, 2, 3. This was A prime over here. And then C is at -3, -1, 3. All right, notice how each point just shifted over one quadrant, and I connect the dots, bada bing, bada boom. I've got my new triangle. Okay, why don't you take a moment, go ahead and pause the video, and try to rotate the triangle 180 degrees and 270 degrees. Go ahead and pause and then check your answer. All right. So if we refer back to, we'll say this is our original triangle here, this one in black. A prime here should be just if I change the sign of x and y. All right, so this is -2, -2. B prime is going to equal -3, 2. And C prime should equal 1, -3. Go ahead and plot those points. -2, -2. All right, -3, 2. And then 1, -3. You can see that's the triangle, my original triangle, but it's been rotated now, that 180 degrees. Okay, and your last one, we'll change colors. Let's do this one in red. To get my A prime, I now need to flip-flop x and y and change the sign of x. Okay, so this becomes 2, -2. B prime is now equal to -2, -3. And C prime is equal to 3, 1. Let's go ahead and plot those points. 2, -2 is my A prime. My B prime is -2, -3. And my C prime is 3, 1. Okay, notice how the shape of this triangle has not changed in any way, just its position on the coordinate plane. Okay, and this is starting from here. Now I've swung around 270 degrees. All right, that's it for rotations. I hope you've learned a lot. If you have any questions, come see me in class. That's all for now.